And there we go. Hello, physics folks. We're going to talk about, this is going to be a short one, hopefully. Let's get my pen going. Let's see, pen color is going to be blue. Oh, we'll go green. Let's see how this works. Oh, it's a little bit light. Let's go ahead and come down here and change that to a different color. Come on. Where is my pen? Oh, let's go. Why not? Let's go red. So we're talking about forces. And definition is any action that's on an object that changes the directional speed of an object. So what we mean by this is that if we have an object at rest, it stays at rest. Well, Newton's law of motion, we'll get on that in next week. But if I act on this, if I apply a pressure or hit it or something like that, I'm applying a force. And it's going to move. Therefore, the force is applied. If it stays there, if nothing happens, I did not apply a force. The thing that must be important when we apply a force, that something has to move. And Newton's first law of force is equal to mass times acceleration. F equal to mass times acceleration. This is going to be important. We're going to be using this all. So with our motion, remember that acceleration is the change of velocity over the change in time. Okay. We'll be able to use that. We'll also, and all the motion equations will fit into this. So if you don't have acceleration, but you got two velocities and a difference in time, you can plug it into here. If you got distance and the velocity and acceleration, you got all those equations to worry about. We'll try to make this simple for this chapter, but you can see how this can get a little bit complicated. Now with units, the SI unit is Newton, capital N. It's also kilogram times meter per second squared. So this is basically, when we're talking about force, we're talking about anything that is applied. So moving a mass with by some type of acceleration. Folks, you gotta stop memorizing these units. Remember, you gotta have everything in kilograms, meters, or seconds squared when we do all these units. And it's important that you need to know this and do the changes in order to get the problems correct. I think that's the biggest mistake I see in a lot of these. So, assignment B is dealing with F is equal to ma, and you got more video with some of the example problems. And before we go on to more complicated and force questions, we're going to look at force diagrams. And basically, what we're looking at is how are we going to map out forces, because this is going to dictate if we got a net force or not. So when we look at free body diagrams, we got a force diagram, and for a car hitting a wall, we got two objects. We've got the car and the wall. Now, up and down is going to be constant. Down is the weight of the car acting on the ground, and going up is ground acting on the car. So up is ground on car, and on the bottom is car on the ground. Going to the left is wall on car. That's the force of the wall on the car. And over here, this is the car on the wall. And so what happens if up and down, say this car, if the force going up is equal to force going down, the car's not going to move. If the force going to the left is equal to force going to the right, it's not going to move. And when we talk about free body diagram, assume that the car is a point, and we draw up, down, and to the left. If we're looking at the whole situation, it's now going like this, and we got two forces going up, and two forces going down. Force of the ground on the car and the ground on the wall. So this is what we mean by free body diagrams. And we want to do is a little bit more complicated, and I'm using stuff from the book to look at this. So the force is when somebody pulls a sled. And here's with this diagram, we got the sled, and then we got the string, and it's pulling at an angle. You notice we're looking at the dot. We're not putting the string over here. It's actually here at the middle or at the center of mass. So there's a string going up, force off the earth, the sled pulling on the ground, and the corresponding force on the ground on the sled is going up. So basically, if I come over here, here's my free body diagram. That's my dot, which is the sled. Going up is earth on the sled. Going down is the sled on the earth. And I got something going up to the right at a horizontal of that. This is my free body diagram. And in the assignment, you're going to be given a chance to draw these things. And it's going to be for practice. I'm not going to grade it, but you need to figure out how to draw these things. Thank you, gentlemen. Have a nice day.